Residual stress can significantly affect the engineering properties and integrity of materials and structural components such as fatigue life, distortions, dimensional stability, and corrosion resistance. The influence of residual stress should be taken into account during the design, manufacturing, maintenance, and repair of different products. It is very important to consider residual stress as a complex problem, including the stages of determination, analysis, and beneficial redistribution of residual stresses. The combined consideration of the above-mentioned stages of residual stress analysis is called residual stress management. The residual stress management concept includes the following main stages. Stage 1. Residual stress determination. Stage 2. Residual stress effect analysis. Stage 3. Residual stress modification. If required, that in turn includes the changes in technology of manufacturing, assembly, and application of stress-relieving techniques. Although certain progress has been made in the development of residual stress management techniques, a considerable effort is still required to develop efficient and cost-effective method for residual stress analysis, as well as the development of technologies for the beneficial redistribution of residual stress. A number of new advanced engineering tools for all three stages of residual stress management were recently developed by Integrity Testing Laboratory Inc., a Canadian company located in Markham, a suburb of Toronto, in cooperation with a group of Ukrainian scientists. These new engineering tools for residual stress management are presented in this video. The ultrasonic computerized complex was developed for measuring residual stress in laboratory and in field conditions. The ultrasonic computerized complex includes a measurement unit with supporting software, a laptop computer with an advanced database, and an expert system that analyzes the influence of residual stress on the fatigue life of welded elements. The complex can determine uni- and biaxial applied and residual stresses for a wide range of materials and structures. In addition, the developed expert system can be used for calculating the effect of measured residual stresses on the fatigue life of structural elements based on the mechanical properties of the material, the type of welded elements, and cyclic loading parameters. The expert system for fatigue assessment and optimization of welded elements and structures was developed to find the optimum way to improve the fatigue life of welded elements without increasing its metal consumption. Major attention was paid to develop the predictive model to analyze the influence of residual stresses and the redistribution on the fatigue life of welded elements under the effects of improvement treatments and cyclic loadings. Optimization of welded elements is based on the fatigue assessment of welded joints in the dialogue mode. The following important parameters of welded structures with the goal to enhance the fatigue performance are analyzed. Material selection. Preferred design of welded elements. Weld processes and materials. Residual stresses. Application of improvement treatments. Influence of possible repair technologies. Realistic service conditions. Ultrasonic peening is the most effective and economical technique for beneficial redistribution of residual stresses and fatigue life improvement. The fatigue testing of welded specimens showed that the ultrasonic peening produces an increase in fatigue strength as compared with traditional techniques such as grinding, TIG dressing, heat treatment, hammer peening, and shot peening. A new advanced system for ultrasonic peening of parts and welded elements was designed based on a power-on-demand concept. A software package was developed for the effective application of ultrasonic peening treatment for different applications and for the maximum possible increase in fatigue life of welded elements with minimum cost, labor, and power consumption. The software is based on an original predictive model. The main functions of the software are determining the maximum possible increase in fatigue life of welded elements by ultrasonic peening based on the mechanical properties of the material, the type of welded element, cyclic loading parameters, and other factors. Determining the optimum technological parameters of the ultrasonic peening, maximum possible effect with minimum labor and power consumption for every considered welded element. Quality monitoring of ultrasonic peening process. Fatigue analysis of welded elements or structures after ultrasonic peening, based on detailed inspection of ultrasonic peening treated zones and computation. The ultrasonic peening process could be used manually and in robotic mode for improvement treatments. The ultrasonic peening complex has been successfully applied to increase the fatigue life of welded elements, eliminating distortions caused by welding and other manufacturing processes, residual stress relief, increasing material hardness, and surface nanocrystallization. Ultrasonic peening treatment efficiency can be evaluated based on ultrasonic measurements of residual stresses in welded elements before and after treatment. The residual stress measurement process involves measuring the velocity of 2 shear polarized waves and 1 longitudinal ultrasonic wave at the specific point of interest. 2 different gauges are used for this purpose. The first gauge measures the velocity of shear polarized wave parallel to the weld. The same gauge is then used to measure the velocity of shear polarized wave perpendicular to the weld. The next step is installing the gauge to measure the velocity of longitudinal ultrasonic wave that is perpendicular to the material surface. The results of these measurements are used for residual stress computation at the point of measurement, measurement of ultrasonic wave velocities in a number of other points, and finally plotting the distribution of residual stress after all measurements are finished. Presented in this video are new engineering tools for residual stress management. Device UltraPeen and Device UltraMars. These could be applied separately or as a system connected through the software package. If you would like more detailed information on engineering tools for residual stress management and fatigue life improvement, please contact us.